So why is the tuner working better now when it was acting so weird before? I can't say for sure. I can say when I took it out, I cleaned up all the switch contacts in addition to lubricating it, cleaned the tube sockets, and then I hooked it back up. I made sure all the connections were very sound. I don't know. I'm just glad it's working better now. There are little screw adjustments through these holes for each of the channels. I'll use my test pattern generator. I'll fine tune it because I know I monkeyed around with them a little bit. And that's why I'm getting reception on both channels 3 and 4 when I have my generator set to, or modulator set to channel 3. When I say this picture tube is dim, I mean it is dim. So here it is with just minimal room lighting. That's with brightness maxed out, and the image gets too washed out at that point. I'm hoping it's a matter of the high voltage being low, otherwise this could just be a very, very worn out 7JP4. We shall see. So next up, I'm going to see if I can figure out how to get this open. I think it's similar to Hallicrafters I worked on. You see there's a phenolic board down there. There are parts on the other side of it. So I think what you got to do is disconnect the few wires that are going into this. There's a hole through the bottom, and there are 4 nuts holding this whole box on. So we undo the wires, remove the nuts, and this whole box then we can remove and flip over. Before we dig that high voltage box out, let's check what the output of it is. That's this black lead coming down here through that insulating grommet. That is the high voltage output of that generator. Got my 6,000 volt probe for my fluke. Put it on there. That is way low. It should be at least 5,000 volts. So we've got about half of what it should be. No, you can't get at it through the top of the box, I don't think. You can see the one paper cap down through the center of that coil, but I don't see the hole for that trimmer cap. So maybe it has to be adjusted with this detached from the chassis. Well, anyway, there's no way around it. We've got to open that up. It turns out there was enough slack. All I had to do was take the 4 nuts off, and the whole thing tilts back. And here are the paper caps I want to get out. Check those resistors, and there's a trimmer cap. And actually there was a hole in the back. I just missed it somehow. You can adjust that from the back side. So I'll be really curious to see what a difference it makes when we get that high voltage back to where it should be. I finished rebuilding the RF generator. I ended up replacing all the resistors and the 2 paper caps. It's not visible at all, so I have no concerns about having to restuff anything. And I want this to be reliable, so it's all metal film resistors. The resistors that were down here were all off spec a bit. So let's give this a try. So there's a variable cap. You can adjust that through a hole in the back. And these 2 are the high voltage filter caps, where typically you see these in magnetically deflected sets. They're called doorknob caps. They're typically good for like 15,000-20,000 volts. I guess they chose to use those instead of high voltage paper caps, which is a good thing because these are very, very reliable. I think that's a little brighter. Let's see about adjusting a trimmer cap in the back. It definitely makes a difference. As If I back off, the high voltage must be decreasing. It's getting dimmer and larger. If I go the other way, it gets brighter and smaller. And if you're wondering why does it get smaller when it gets brighter, simple. More high voltage is accelerating the electrons faster to the front of the CRT face, which means you need more voltage in the deflection plates to deflect it. So when you increase the high voltage, the picture gets smaller. There are height and width adjustments, so I can compensate to some extent. What I really need to do is get my high voltage probe, and then I say to adjust it for, what was it, 4,500 volts, 5,000 volts, something like that. Maximum spec on the CRT is 6,000 volts. So generally somewhere between 5 and 5,500 is a good place to be. No matter what, these set of picture tubes are always best viewed in a dim room. But anyways, that certainly seems to have taken care of that problem. So what next? Well, I got a new hot glue gun. I got out my glue sticks with dark brown glue, so I can start redoing restuffing the capacitors. I've been making steady progress restuffing the caps. These are all ready to go back in. I'll see if I can demonstrate my process here. We're going to restuff a 0.02 microfarad 400 volt cap. First thing I'm going to do is turn my heat gun on and grab the cap by one of the leads with some needle nose pliers and get some napkins or paper towels handy. What we're going to be doing is heating this up in 2 stages. First stage, to wipe off the outside coating, which is beeswax. Then we need a little more heat to undo the plugs on the end, which are higher temperature wax. The goal is to get this clean and empty so it looks something like this, just a cardboard tube ready for a new cap to go inside. So I'm going to start it on low. Beeswax melts at a fairly low temperature. So sometimes when you see wax pooling up around an old cap, it doesn't necessarily mean it's bad. It may have just been near a tube or some other components that got hot and melted the outside coating. They did that just to kind of waterproof and seal it. And you see later caps like the Bumblebees, somebody thought, well, hey, we know wax doesn't hold up that well to heat, so why don't we use a plastic outside wrapper instead of wax. Problem is the paper deteriorates inside regardless of how well you seal it. It doesn't really matter that much. There's just no hope for paper caps. Unless maybe you use some type of archival acid-free paper or something. Anyways, so there's the outside wax gone. Now let's do the ends. Go up to high for that. I keep it moving because I don't want to drip any wax down into my heat gun. Small caps tend to go pretty fast. Good enough. Sometimes the ends just pull out like that one did, not a problem. We'll just switch our needle nose to the other end. Sometimes both ends pull out, real common, and then to get the remainder of the insides out, I'll just poke it with my needle nose. And finally, there's the actual capacitor. And here's the cardboard tube. It's not really hot anymore. Paper doesn't retain heat for very long. A little bit of crud on the end. We'll just heat that gingerly, so we'll burn ourselves and wipe it off. They're not going to come out perfect. Some of the wax will get impregnated in the paper, and that's just the way it is. Alright, so there we go. Empty cardboard tube. So now we find ourselves a new capacitor. We need a p5o. I'll just use one of these generic yellow guys. And notice, hey, it's too small. Yeah, wrap some tape around it. Electrical tape, ideally, because you don't want to put anything conductive around it. Alright, let's give that a try. This is probably the most tedious part of the whole process. Getting the new cap seated in there securely. Alright, I just want to kind of space it so it's in the middle. And now we want to plug up the ends. And how can we do that? Well, brown hot glue. Got some nice dark brown mini glue sticks and a glue gun, and we're going to fill up the ends. I'm not trying to get it perfect on this first pass. I just want to get the cap kind of secured and centered in there. I don't worry about making it look nice. Alright, I'll let that cool for a minute or so, and then I'll come back and clean up the ends. Now I'm just going back over to clean things up. Often a little air bubble will form. Just put a little more glue in there and run the hot tip all around to smooth it out. Use my fingers to kind of clean off the excess. And then if it's still a little ugly, you can just hit it with a heat gun and kind of reflow it. Alright, and then for the final touch, I have been coating them with some wipe-on satin polyurethane, just applying it with a Q-tip, and then I stick it into a foam block for a couple hours for the poly to set up, and then there you go, ready to be reinstalled. With that polyurethane, it makes it really nice. It has a kind of a satiny look like the old ones did, but dirt isn't going to stick to it. And you can see the graphics and the value very, very cleanly. Do you need to do this? No, of course you don't need to do this. Is it going to make the set work any better? No, of course not. I'm doing this for a few reasons. One, just to show you how it can be done. Two, I like to mix things up to keep myself interested in the hobby. I've been doing this off and on for 35 years, so you know, it can get a little boring at times. And just you know, as a challenge, and finally to preserve history. For what it's worth. I mean, this is a rare-ish set. I've never seen this brand of capacitor before. They're in really good shape, so why not? Let's do one more. I'll do one of the much larger ones this time. This can get a little bit messier, as you can imagine. A lot more wax to get off. And I'm just going to go right to the higher heat for these bigger ones. You can do this in like a toaster oven. But one thing you're going to want to do is not just lay them on their sides like in a cookie sheet, because then they will just sit in a pool of wax as this melts out, and you're going to get a mess. You're going to want to do some kind of mesh screen or stick them so that they're standing up on their ends, so that as the wax melts, it can flow away from the cardboard tube. Don't do it in your regular cooking oven or anything you might use for food, because the wax is going to, some of it's going to vaporize and it's going to settle on the interior surface. This harder wax, if you get it hot enough, it smells quite a bit. I don't know of any solvent that will dissolve the wax. Lacquer thinner doesn't really seem to do it, or at least not in any significant way. But that would be interesting, because I would like to know if it's possible to do this without having the cardboard discolor, or a way to do it without heat. See, especially with these light tan ones, they seems like a little bit of that higher temperature wax kind of impregnates into the cardboard and darkens it. And maybe it was already like that. Maybe it was like that from when they made it. I don't know. Maybe there is nothing that can be done about it. It's the only thing I'm not crazy about with the way these are turning out. Otherwise, Industrial Condenser Corporation, Chicago. Very cool. So now we need a 0.25. Well, 0.22 is close enough. Rated at 400 volts or better. Here's my new cap going in. And just like before, we fill it up with hot glue. For these larger ones, you need considerably more. I start out just putting a bead around the outside, and then I'll let that set up a little, and then I'll finish it off. So, it's been moving along pretty quick. I've done more than half of them. It's taken me, I don't know, half an hour, probably less. The only real time-consuming part is having to wait for the wipe-on poly to dry. So I'm kind of doing them in batches. Once I get a bunch more of these done, I'll coat them. Wipe-on poly, that's really easy to do. Just need to pop the can open. I've been applying it with these cotton swabs. So here's the one that I just restuffed a moment ago. I'm just going to dip the swab in the wipe-on poly and then just go all around. One coat seems to be sufficient. This will take, maybe 2, 3, 4 hours to dry enough that it's not sticky. I've just been sticking them into a styrofoam block while they dry. And so notice how some of them don't discolor, like this one is especially nice. And these light colored ones discolored a bit, as do the orange. This one turned out pretty nice too. Alright, let's get back to this guy. Feed in some more. Try to keep it centered. And let that sit a bit and then do one final pass to clean it up. While we're waiting for that, outside foil, let's talk about that a little bit again. endlessly get comments about, hey, do you check for the outside foil? What about the outside foil? What about the stripe? What about the new caps? Okay, so the old caps, we can see one here. They are made out of foil and paper. And when I say foil, I mean foil, like aluminum foil, like a sheet of metal foil. And on the cap, they would mark which side was the outside foil, meaning the outermost layer, like in this case, it would be this. And this would be going to this lead, and the other side, inside, or the other jelly roll foil piece would be going to the other end. Why aren't new caps marked? New caps aren't marked because they're not made out of metal foil. They're made out of metallized plastic film. What is metallized plastic film? Well, you've probably seen Mylar sheets, like Mylar balloons, or they put them on windows sometimes to reflect heat or decrease the amount of light that gets through. It's metal that's vacuum deposited onto plastic, and it's so thin you can literally see through it. It's just a few atoms thick. It's my understanding they stopped marking the outside foil on capacitors because it effectively offers no shielding because it's so thin that it just doesn't really matter. It's not significant. I'm not saying there's no difference. Yes, I know there are tricks you can do. I know you can determine which side is the outside foil. My assertion is that the difference is so minimal, it's not going to make any difference. They stopped marking it for a reason. They didn't just stop marking it on a whim. And yeah, we switched from using tubes, but they were still using tubes when they stopped marking the film caps. And there are FETs that are super high impedance too. And my other assertion is that even if it did matter and it was important, nothing else is shielded. You've got wires going all over the place. You've got resistors. You've got long leads. None of that is shielded. Yeah, it's not coiled up in a tube, sure, but I've yet to have somebody demonstrate to me, like outside of a lab, in a real-world device, where putting the capacitor in one way versus the other made any significant difference. So that is why I don't check, and that's why I don't care. Alrighty, I'll just hit that with the heat gun a little bit to clean off, or to kind of reflow the ends a little bit, and then I'll coat it in poly, let it dry, and that is that. While I'm reinstalling the paper caps, I'm also checking all the resistors, and it was inevitable I was going to find some that were out of spec. Now, what am I going to do about that? They still do make carbon comps on half watt you can generally get, I think, from Mouser Electronics, but they're expensive, like 50 cents to $1 a piece, I think. The 1 and 2 watters are really hard to find. You're pretty much going to have to go to eBay or an audiophile site and be prepared to pay for several dollars each if you can find the value you need. Luckily, I have a limited stash of new old stock. Well, and I did finally run into some that were far enough out of spec I think I should replace them. And in this case it is, or they are rather, the 2 plate resistors on the horizontal amp. That's what feeds the deflection plates. Both these 47Ks are measuring way high. Measure one of them again here. So this should be 47K, and it's 118. It's more than double the value. If it was within 20-30%, I'd let it go, but that's just too far out. So let's check out one of these new old stock. How old are these? I'm not sure, but decades for sure. I just hope it's close enough. Can you guys see that? The reflection on these meters is pretty bad. 50.8. That's close enough. I'll use it, especially if I can find another one. I've only got 4 to choose from. I also want them to match each other fairly well. It's 51.7. See, these go high just sitting around. Alright, that's pretty darn close to that first one. So I'll set that aside. Oops, I guess this is what you would call hand-selected matched components. Oh, that one's way high. Alright, I'll go with these two. They were within like 1% of each other. So the originals are buried pretty deep in here. But I'll do what I can to dig them out. They're also rather discolored. At first I wasn't sure what value. I thought they were 10K or something like that. I couldn't really read the colors, but it's this resistor right here and this guy. This trimmer cap is a horizontal linearity adjustment. So I'm gonna, well, I'll try to do it without having to undo this stuff, but I may have to. I may want to anyways, because I need to install the rebuilt high voltage caps here. I got one of them installed so far. This is original. That's how they did it. This is one of the filament string droppers. It's supposed to be a 50 ohm 10 watt resistor, I think, and they put a couple hundred ohms in parallel, and it's just floating out here. That's how it's supposed to be. Here's one of the resistors I want to replace. It's measuring 84K. It should be 47K. This lug isn't too bad, but the one down here has several things going to it, including the stub remains of the old high voltage cap, and has a new one I tacked in. So first I'll take out the one I tacked in. Next I'll try to get out the remains of the old one that was clipped out long ago. And then we'll work on getting that resistor out. What I try to do is, like, I freed up this remains of the lead, I get it to a point where I can cut away at it rather than trying to desolder the whole connection. Now, it turns out on that tube socket pin, that is all that goes there, is that one resistor and a high voltage cap. So let's see. I'll clip the resistor out at the top, and then see if I can start kind of wiggling it loose on the other connection. See, it's done at the bottom part of the socket. There are 2 lugs on each one of these tube socket pins. There are two holes in them for component leads. The resistor that used to one that's deeper in. Those little parts are pretty fat leads, so they can be a little hard to work at. And what I'm trying to do is to clip it rather than trying to unwrap it. So if I can cut it on the bend, and then I just have 2 little pieces to work out rather than trying to unravel the whole thing. So ideally, once I cut that, the 2 pieces will just fall out. Yeah, so there's the resistors loose now. I ended up just breaking off the other end. That's alright. I'm not going to be trying to reuse it for anything. Just going to get that little bit of wire remaining out of there. So bit, and the other end is kind of stuck around the tube socket now. Finally, there we go. Alright, so the tube socket lug is all cleared out. Now I need to get the little stub out of the terminal strip. And I can finally install my new resistor and rebuilt the cap. This lug's a little bit tricky because there are several wires going to it as well. Same deal, I was able to push it, which got it partly dislodged to where I can cut it, and then I can just pick out the two little remaining pieces. Alright, so I cut it. So no solder sucker, no desoldering braid, no desoldering pump or iron kind of thing. Just a little heat and nipping and tucking and patience. I think they got it all out. Alright, now just put new parts in. Just about done getting the new part in. These heavy component leads are not fun to work with. I do not want to stress out that tube socket and risk breaking the lug, but I also want to make a secure physical connection before I solder it. And I also am not, well, let's just say it makes it more challenging to record this while I'm working on it because the camera keeps getting in the way. But I know you guys want to see some action, so I'm trying. Okay, I'll touch up the other end. Cool. Like a big old capacitor, high voltage cap, will get threaded up through and in there. And it goes below and in between the filament dropper resistor. Down around through that way. And of course I'm going to orient these rebuilt caps so you can see the nifty graphics on them. Alright, that leaves that guy to replace. I hope there aren't many more resistors that need to get replaced because they definitely take more time, especially when they're buried several levels deep behind other components.